Okay, we're to solve this 3 by 3 linear system using Cramer's rule. Each of these is the equation of a plane in three-dimensional space. And if you look at a corner of a room, of any room, you'll see three planes intersecting at a point, which is what we're trying to find, that point of intersection. So first we have to find the determinant D, which is extracting all the coefficients from the left side of these of the linear system here. So 2, 6, 4 is the x column, coefficients of x. The coefficients of y in the y column here are 1, -1, and 3. 1, -1, and 3. And then for z we have -2, 2, and -1. Now for Cramer's rule, you start by copying these first two columns over here. That makes it easier anyway. And so here we go, calculating our diagonals. We have 2 times -1 times -1. So that's -2. I'm sorry, +2. Because a negative times a negative is a positive, so that's 2. And for the next column over, we have 1 times 2 times 4, that's 8. That yields an 8, so +8. And the next diagonal over is 2 times 6 times 3. -2 times 6 times 3. See, that's 12 times 3. -12 times 3 is -36. Okay, now we subtract what we get on the diagonals going in the other direction. So we have 4 times -1 times -2. 4 times -1 times -2 is 4 times 2 is 8. And for the next one over, we have 3 times 2 times 2. 3 times 2 times 2 is 3 times 4 is 12. So we add 12. And then for the last term, we have -1 times 6 times 1. -1 times 6 times 1 is -6. So we're at -6 here. So we end up getting 10 take away 36 is -26. And we're subtracting from that 8 plus 12 is 20. Take away 6 is 14. So our D in this case is equal to -26, -14. Let's see, 6 plus 4 is 10, carry the 1, and so 10 carry the 1, so 40. -40 is what our D equals for this system. Okay, so now we have to find 3 more determinants to finish this problem off. And the first one we'll find is D sub x. D sub x is what we get when we replace the first column here. Instead of 2, 6, 4, we use 3, 1, 1. We cover the x column with what's on the right side of the system, 3, 1, 1. The y and the z columns are the same as they were here, so 1, -1, 3, and -2, 2, -1. Now we copy the first two columns to the right of the matrix, and we begin our process of multiplying down diagonals here. So 3 times -1 times -1 is +3. 1 times 2 times 1 is 2, so we add 2. Then we have -2 times 1 times 3 is -6. And then we subtract from this the product of the diagonals going the other direction. So 1 times -1 times -2 is 2. Then we have 3 times 2 times 3. 3 times 2 times 3 is 6 times 3, 18. And then finally, the last diagonal here is -1 times 1 times 1. -1 times 1 times 1 is -1. So what we have here is 5 minus 6 is -1. Minus, in parentheses here, let's see, that's 20, take away 1 is 19. So minus 1 minus 19 is negative 20. So that's our d sub x. So now that we know d sub x and we know d, we can find x. Because x is simply d sub x divided by d. D sub x we found to be negative 20. D we found to be negative 40. And negative 20 divided by negative 40 is 1/2. So the x coordinate, so here's the x coordinate of our solution point, is 1/2. We still have y and z to find.